The lithographic printing is a technique of mechanical reproduction of images that was introduced in the late 18th century and that became successful only in the following century. From a technical point of view, this technique is mostly based on the incompatibility between some inks and water, but in particular, it is based on a phenomenon that was well known even at that time, that is, the mutual repulsion between water and greasy substances. Without, of course, explaining in detail its functioning, since it's very complex, we can say that lithographic printing gave its contribution to spread the serial reproduction of images, setting the stage for the age of reproducibility of art. Well, even if I would be tempted to talk about Andy Warhol, I stop here with my college memories, also because I think you are not here for this, and maybe you are not very interested. Nevertheless, I inform you that today we are going to talk about printing processes, and more precisely about the digital printing process that even in ceramic shows the same repulsion and repellency phenomena due to the different chemical features of inks and glazes. We will try to understand what happened before and after the digital printing process, and we will offer some ideas about the actions that must be taken to avoid problems during production and to produce, at the same time, of course, high-performing ceramic products. I finally let you know that since the topic is very long, we decided to split it in two parts. We will start today our journey, and we will arrive at the end of it only in the next episode. I am Davide Trentini, and this is Apparently Invisible: Chemistry in Ceramic. As we know, the digital ink application that has replaced the traditional decoration systems by means of screen printing or silicone rollers has eliminated several critical issues, bringing out, however, new and, we could say, more complex problems. What kind of problems are we talking about? Well, the list could be very long, but the most popular ones are for sure the water repellency phenomena that can arise because of the lack of chemical compatibility between digital inks that are based on non-polar solvents and the water that, as we know, is the most representative polar solvent and that is within the glaze suspensions used along the production line before and after the digital printing application. So, I repeated, the problem is mostly due to this opposition or aversion between the polarity of the solvent-based inks and the water-based application of the glazing line. But that's not all. In fact, the second important issue that arises is the possible improper absorption of the glaze on which digital inks are discharged. And this improper absorption can sometimes negatively affect the printing definition. So let's start by taking a closer look to the last problem, that is the glaze absorption. That is the problem that concerns the applications before the digital printing process. Later on, instead, we will address the problems that may arise after the inks application. Okay, in general, it is unusual that along the glazing line, a glaze applied on the ceramic surface reaches the digital printing machine when it's still overly wet. What does that mean? It means that the amount of water in the glaze suspension applied before the printing process tends to evaporate before the raw tide reaches the print heads that discharge the inks. We are saying, in other words, that the polarity of water hardly meets the non-polarity of the solvent-based inks. This is the reason why digital inks rarely show repellency phenomena with regards to the glaze applied before the digital printing process. However, sometimes a particular glaze could be marked by an improper drain values, that means poorly or excessively draining, that negatively impact on the following stages of the process. In both that cases, it would be important, if not necessary, the use of a specific category of chemicals, and we are talking about primers. What is a primer? Primers, and this is true not only in the ceramic field, are all those products applied to a surface able to create the technical proper preconditions for the following applications, and the word itself says it. In our case, and so in ceramics, We are talking about a chemical that must be added within or on the glaze and that is able to avoid some of the problems that may arise during the application of solvent-based digital inks. Among all these problems, which are the most frequent? Well, first, excessive or improper drainage of the glaze. Second, an uneven absorption of the inks by the glaze support. Third, excessive accumulation of water vapor. Let's start from the first one. In the case of a too draining glaze, the ink might sink too deeply inside the glaze and therefore the amount of ink that is discharged should be increased to reach a good result. In this regard, try to think about a glaze that does not remain in its position, or we could say in the position it should have. For example, when the decoration is applied on smaltobbio, that is usually marked by a white matte color, the penetration of the ink in the deepest layers of the glaze leads, after the firing cycle, to a poor visibility of this ink, since the ink is inside a matrix that is white and opaque. Despite this scenario is quite uncommon, the glaze, that is not very plastic, is in this case marked by the presence of many inorganic raw materials that, even if they are cohesive, they are, we could say, distant, since there are many empty spaces between one and another, and so the ink easily sinks in the deepest layers of the glaze. To avoid or reduce the problem, a preventive action is required, that is, the addition to the glaze of a proper primer able to create a reticulation between the particles of the glaze, reducing or limiting the penetration both of ink and solvents. Of course, the kind and the amount of primer that is used defines the dimension and the grid between the particle and so the drainage. That said, in some cases the scenario could be completely different and we could have an opposite problem. The glazed support, in fact, can be marked by a very low drainage that turns into a significant loss in terms of printing definition, especially when the graphic project involves the use of a high amount of ink. In all these cases, the best action, even if it's surely drastic, is to carefully study and analyze the chemicals in the suspension and then check the glaze or engobes formulation, revising all the parameters until the best drainage condition has been reached. In some cases, it is also useful to decrease the amount of those organic and very plastic raw materials that tend to reduce the drainage values. The main target is, of course, the formulation of chemicals able to promote the best rheological conditions for the developing of a more open reticulation within the glaze, allowing the ink to sink through the superficial layer and so improving the drainage. To make this happen, of course, from a chemical point of view, it is recommended to limit the use of binding polymers by using chemicals that can make the system cohesive without producing a film-forming effect. What does that mean? In very simple words, these chemicals that can be added along the glazing line are able to put a distance between the inorganic particles of the glaze by creating or producing a grid or a reticulation inside the suspension. Okay, so let's now address the second item of our list that, as we have seen, is all about the possible uneven absorption of the ink by the glaze that has been already discharged on the raw ceramic support. In some cases, raw tiles, especially those that present a structured or textured surface, can unevenly absorb the ink, forcing ceramic producers to use specific primers, that is binders or wetting agent, capable to eliminate these differences. How do they do it? Glues or binders can improve the glaze performance in terms of leveling by increasing the drying times. This means that they provide the glaze with more time to develop a proper leveling process, producing at the same time an organic reticulation that in most cases helps to standardize the drying times of the different parts of the tile. In other cases, wetting agents, since they reduce the glaze surface tension, can sometimes even reduce, we could say, the distance between the surface tension of the ink, that is solvent-based, and of the glaze, that is water-based, leading to a better ink reception by the ceramic support that in turn leads to a more homogeneous absorption. It is finally important to remember, and that ends today's episode, that wetting agents also facilitate the homogeneous distribution of the glazed solid particle by a deagglomeration process, therefore promoting and improving the homogeneous and uniform application. And with this second point, I stop here our journey, and I confirm that we will end the subject in the next episode. In the meantime, I remind you, and this is almost a mantra, that all episodes are available not only on the main platforms such as Spotify, Apple, Google Podcast and Spreaker, but also on our app that you can download for free on Apple Store or Google Play. You can find it by typing Z&S Ceramco, Ceramco. While you are waiting for the next episode, I invite you to think about this question. How would the world be today without the reproducibility of images? Better or worse? See you soon.